Okay, now that the data is cleaned and transformed, we can move into the most important stage of the project, that is the insight generation. So, what is insight generation? Insight generation is basically since the stakeholders um, have given us certain questions, right? And since we have analyzed the data and we have done the data cleaning, transformation, and everything, right? Data normalization. So now we have the data to actually answer those questions. So what I will do here is I will make this series like I will answer every question in one video because that would be very easy for you instead of just making one business insight generation video. So moving on, what we have done here is we have to calculate the average occupancy rate in each of the room categories. So as you can see, we use the data frame of aggregated bookings, uh, CSV, and that's why we use df aggregated bookings dot head. Head basically is the default. It gives like 5 rows, but here since in the parenthesis like the bracket we have mentioned 3, so it is giving us the 3 rows. So as you can see, we can really see the room categories and occupancy percentage. We need to calculate the mean. Mean is basically calculates the average of the room category. Uh, basically, room average of the occupancy percentage. So that's how we use the code, that is df aggregate bookings dot group by. So what does group by do? It actually separates the data into groups such as RT1, RT2, RT3, and RT4. Okay, and then I use the OCC PCT, that is occupation percentage column, because occupancy is a matrix I want to analyze, right? So yeah, then we use the mean. Mean calculates the average. The result shows that occupancy is fairly consistent across all 4 categories at roughly around 58 to 59%. So I hope it's very understandable. Perfect. Now I need to enrich this result with actual room names. So what we do here is we connect the room codes to room classes. Okay, so room classes, as you can see, is standard, then there's presidential, then there's, yeah, there are like different kinds of room classes. So what we do here is first we do the merge, aggregated bookings, rooms. So we do the left on room category. It actually tells Pandas which columns to use from the booking table, while right on is equal to room ID identifies the matching key in the room dimension. So RT1 can now be understood as standard, RT2 as elite, then RT3 as premium, and RT4 as presidential. So this is essential, the Python version of connecting a fact table with a dimension table. Remember, this is like fact connecting the fact table and dimension table. Okay, super important. Uh, so then moving on to removing the duplicates joint column. So we use the code df.drop room id comma access is equal to 1 in place is equal to true, and df.head 4 in parentheses. So we get the 4 rows. So what we are dropping here, first of all, after the merge, both the original room category and the dimension room's ID are present. Since they represent the same key, I don't need both, right? So I use drop to remove room ID. Access is equal to 1 tells Panda that I am removing a column, not a row. Access is equal to 1 tells Pandas that I am removing a column, not a row. Remember that. Why we use access equal to 1? Basically it tells Pandas that I'm removing a column, not a row. So, and in place is equal to true means the change is applied directly to the existing data frame. In place is equal to true means the change is applied directly to the existing data frame. So That is the thing, and that's how then we would get. Uh, so now you see, we get the average occupancy by room class. We use the formula df.groupby room class and occupancy percentage dot mean. So now I repeat the occupancy analysis using the descriptive room class. This result shows the standard is approximately 57.89%, elite is around 58.1%, premium is around 58.3%, and presidential is around 59.28%. So you see, presidential rooms have the highest average occupancy, but overall, the difference between room categories is relatively small. This tells us that occupancy is fairly balanced across the room portfolio. Be careful not to overstate the difference. It is only around 1 percentage point. Now, let's filter a specific room class. For example, if we use df room is equal to standard dot oct, right, occupancy percentage dot mean. So here I am demonstrating another way to answer a specific question. Instead of like grouping all room categories, I filter only records where room class equals standard. Then I calculate the mean of occupation percentage, that's OCPCT. This gives me an average of standard room occupancy of approximately 57.89%. So this type of Boolean filtering is useful when we want to investigate one specific segment rather than compare all segments together. Perfect. We'll move on to the next question on the next video. Thanks so much for watching. I hope you learned something from this.